Hello and welcome to this video about velocity time graphs. Again, like I said when we looked at distance time graphs, whenever you see a graph like this in your exam, you must first of all check that you are talking about velocity. So I'd recommend actually in the exam to read this axis carefully, circle it to make sure, underline it to make sure that you know you've read it, so that you know you're talking about velocity over time as opposed to distance over time, which is a completely different graph. So let's talk about what velocity means first of all. Velocity is speed with direction. And what we mean by that is normally we give a value for speed, for example 10 meters per second. And if we're talking about speed, we would give no indication of the direction that the object was travelling in. However, velocity, that value implies a direction as well. So for example, you might put 10 meters per second to the right, for example, or 10 meters per second north. So with velocity also comes direction as well. But you should start to think about velocity and speed as being two very similar things. So again, you might be given data in a table such as this, where you've got time and velocity in meters per second of an object, and you might have to draw a velocity time graph using that data. Or you might get presented with a velocity time graph like this, which you have to answer some questions about. So first of all, let's have a look at what the different parts of the graph mean. So if we label them up, A, B, C, D and E. If you have a look between A and B, if we're describing the motion of the object, well, it's going from 0 meters per second to 40 meters per second over time, so it must be speeding up or accelerating. It then goes from 40 meters per second to 80 meters per second, so again it must be speeding up and accelerating. Between C and D, it stays at 80 meters per second, so that doesn't mean it's stopped, because it's travelling at 18 meters per second. In a distance time graph, the flat bits meant that the object was stopped. Not in this case. If you read carefully on the axes, you see that the object is travelling at 80 meters per second. So at this point, it's just at a constant speed. And between D and E, it starts at 80 meters per second and goes to 0 meters per second. So it must be slowing down or decelerating. So here we're slowing down or decelerating. Between C and D we're at a constant speed. Between A and B we are speeding up or accelerating, and the same for B and C. If we compare the acceleration between the two, we can see that the steeper the gradient, so the steeper the line, the higher the acceleration. So on velocity time graphs, the gradient means acceleration, which is measured in meters per second squared. Okay, so gradient is acceleration, and then the steeper the gradient, the faster the acceleration, or the higher the acceleration. What I want you to look out for in the exam is the terminology that they use in the questions, which is often something like describe the motion. Okay, so describe the motion of the object between A and B, or describe the motion of the object between C and D, for example. So all that means is describe how it's moving, whether it's speeding up, whether it's staying at the same speed, or whether it's slowing down. So if you see that word motion, think about telling us about the speed of the object and what it's doing. Okay, that's it for the foundation content for velocity time graphs. The next few minutes will be about the higher content. Okay, so this extra bit is for higher tier only. We said earlier that the slope of the line, or the gradient, tells us the acceleration of the object, and for higher tier we just need to be able to calculate that. So if we put some letters on here to help break down the graph, if we say call this A, B, C, D and E, we said the flat line was when the object was at a constant velocity, and the slope going down was between D and E. The object was decelerating. So let's concentrate on calculating acceleration between A and B first of all, and then C and D. If we look at the acceleration between A and B, first of all, we need to draw a triangle on our graph to help us identify the values, and we're going to draw a triangle down like this. When you're in the exam, do this with a ruler nice and accurately. But we can look at calculating the gradient, so y, difference in y, divided by the difference in x. So for A and B, we've got a velocity of 40 to 0, so 40 meters per second, divided by 50, 60, 70, 80 seconds, and that will give us our acceleration. So if we use 40 meters per second divided by 80 seconds, we will have our acceleration of 0.5 meters per second squared. Those are the units for acceleration, meters per second squared. If we then look at the acceleration between B and C, we need to draw a triangle on our graph to help us. I'll do it in a different colour so we can see. So if we draw a triangle on, again you should really do this with a ruler in your exam. We need to find the difference in y here and the difference in x here. So if we kind of extend these dotted lines down to the axes, it will help us. So first of all go across here. We're looking at the difference between 80 and 40, that's our y, so we've got 40 meters per second here, and for the difference in x we've got between 80 and 120, so the difference between 80 and 120 is 40, so our x value is 40. So here we've got 40 meters per second for the y value divided by 40 seconds for the x value to give us an acceleration of 1 meters per second squared between B and C. And you can see, because this is the steeper gradient, this has got the higher acceleration of 1 meters per second squared, compared to between A and B where the line is slightly shallower, we've got an acceleration of 0.5 meters per second squared. And this calculating the gradient links into an equation which you'll get on your equation sheet, which is A equals V minus U divided by T. And we'll talk about this in another video when we do some calculations, but A is acceleration, V is final velocity, U is initial velocity, and T is time. So acceleration equals the difference in the velocities over time, and that's exactly what you've done here. You said acceleration is the difference in the velocity over time. So this equation, a equals v minus u over t, is how you calculate acceleration, and that's essentially what we've done using the graph. Okay, the final thing that you might have to do with velocity time graphs if you're taking the higher tier is to calculate the distance travelled by an object. And to do that, you just need to work out the area under the line or the graph. Okay, they might ask you to do the distance travelled between 2 points, or they might ask you to do the entire distance travelled. So if we just add A, B, C, D, E here to help us, if they said what's the entire distance travelled, you would have to calculate the entire area under the graph. But let's suppose that they ask you what is the distance travelled between C and D, for example. To do that, you'd have to calculate the area under the graph for the section C to D. So to do that, if you take your ruler and you meet the axes, draw a dotted line down to meet your axes, and do it the same at point D. Then you need to calculate the area here. So you've drawn a rectangle in this section. So the area of a rectangle, you would have one side multiplied by the other. So in this case, we would have a look at our values that we've got. So this is between 120 and 160. So this value is 40. And along the side here, we go from 0 to 80. So this value here is 80. So to calculate the distance travelled between the sections C and D, we simply do 80 times 40, which would give us 3,200. So 80 times 40 to give us 3,200 meters. If we look at another example, if we say the distance travelled between A and B, so we're looking at this section of the graph. Again, you should draw your line down to the axes. And this time, because we've got a triangle, we now need to calculate the area of a triangle. So to do that, we need to times this side by this side, and then remember to divide by 2. Because if you just times this side and this side, you'd be calculating the area of that whole rectangle, but we just want half of that because you need the area under the line. So this value here is going to be between 0 and 40, which is 40. And this value here is between 0 and 80, which is 80. So again, we have to do 40 times 80 to give us 3,200. But this time, because it's a triangle, we have to then divide by 2. So 3,200 divide by 2 to give us 1,600 meters. So just to clarify, if you just left that as the 80 times 40, you would not only be calculating this area, but also this area as well, because you've just done the area of a rectangle. You must remember, if it's a triangle, to divide by 2. That's really important, and that's the bit that most people forget to do. If you had a little bit more of a difficult section, for example between B and C, you would have to split your shape up into a couple of sections to help you out. So for example, if you wanted to find the distance travelled between B and C, you would first of all have a look and calculate the area of this triangle, and then you would calculate the area of that rectangle and add them together to calculate the distance travelled. Okay, so this is the extra little bit for the higher tier. Calculating distance travelled using area under the graph, and also calculating acceleration by calculating the gradient. If you found this video useful, then please press the like button below and feel free to subscribe. Thanks for watching.